Hello everyone, welcome to the second part of the video. This is still all about trigonometric equations. So this time we are to find all solutions of cosine x equals 2 over 5. So we have now an equation involving a cosine function. So we will take this illustration because the cosine function is positive. And remember ASTC, the cosine function is only positive in quadrant 1 and in quadrant 4. Now, using inverse trigonometric idea, we have the cosine of, this should be the inverse of cosine 2 over 5, or that is approximately 1.16. Okay, so the angle is actually this one. This in the illustration, this orange angle. For x sub 2, we have to take 2 pi minus 1.16. Okay, 2 pi, remember, is a full revolution in terms of radian measurement. That means that's full revolution 2 pi minus 1.16, which is the reference angle. So in short, we have an x value approximately 5.12. All coterminal angles of x sub 1 and x sub 2 again will be considered solutions of the equation since there's no restriction of the interval, or that means we are to consider the interval negative infinity to positive infinity. If we consider some conditions like find all solutions at the closed interval from 0 to pi over 2, then x sub 1 will only be 1.16, or there's only one value of x which is approximately 1.16. If we extend until quadrant 2, just like what we did in the previous video, that will just be again 1.16 since there's no terminal side in quadrant 2, or we will not consider any values in quadrant 2 or quadrant 3. If we extend until quadrant 3, there's still one solution. And if we extend one full revolution, we have these two values, x sub 1 equals 1.16 or approximately 1.16, and x sub 2 which is approximately 5.12. If we are to take the negative side, you have negative pi over 2 or 0, to 0. So you have negative pi over 2 up to 0 here. Then there is actually one terminal side that we considered. So in short, we are to take the value of this terminal side, the angle, okay? We are to take the value of the angle rotating clockwise. So that should be x equals negative 1.16. So from the x-axis moving down, that's clockwise rotation, that should be a negative angle or negative 1.16 approximately. If we extend until the negative pi, so that should be 0 to negative pi or negative pi to 0, then there's only one terminal side again, so that should be negative 1.16 approximately as well. If we extend until negative 3 pi over 2, it's the same way, that is still negative 1.16 approximately. And if we extend one full revolution with clockwise rotation, then you will consider the two values. First is you have negative 1.16 here. Okay, that's a clockwise rotation from the right side of the x-axis. And this rotation clockwise going to the other terminal side. So that should be the solution, negative 2 pi plus 1.16. So in short, from the right side of the x-axis, that should be one full revolution clockwise, so negative 2 pi. And then we have to go back until the terminal side, so plus 1.16. Plus, because the rotation now is counterclockwise. That should be approximately negative 5.12. Okay. So another example, you have find all solutions of tangent x equals negative 7 over 5. So this time we have a tangent function or an equation involving tangent function. So this will be the scenario. Remember, okay, we have to consider the value here, negative 7 over 5. And again, tangent is positive in quadrant 1 and quadrant 3. Remembering ASTC, okay, ASTC is our basis most of the time. Very important, at least. Okay, so you have ASTC, tangent is positive in the first quadrant and the third quadrant, and so tangent is negative in the other quadrants, specifically in quadrant 2 and quadrant 4. Okay, so that's why the illustration looks like this. Now, inverse tangent of negative 7 over 5 is actually negative or approximately negative 0.95. Now that's a negative angle, so that means there is a clockwise rotation or this angle here, the green angle in the illustration. But actually, in terms of reference angle, that is a positive angle, positive 0.95. But of course, since we consider the rotation clockwise, so that's why we have a negative 0.95. Now the x sub 2 is pi minus 0.95. Okay, so this should be pi here, pi. It's pi angle here until the negative side of the x-axis minus the reference angle is actually approximately 2.19. Okay, in the same way again, if you want to check your solution, then you may just substitute the value of x to this variable. This should be tangent of negative 0.95, and expect that the value for the value of tangent negative 0.95 is approximately negative 7/5. Of course, we cannot get the exact value since our x value is also an approximate. Okay, that's actually the angle, our approximately 2.19. And then we subtracted that angle. So pi minus 0.95 basically. Again, same way, all coterminal angles of x sub 1 and x sub 2 will be considered since, okay, since there is no restriction of the interval. Or in short, we consider the interval from negative infinity to positive infinity. Now, if some conditions will be applied, okay, let's say we have the interval from 0 to pi over 2, that's the first quadrant. Okay, so notice in the first quadrant, there's no terminal side. That means none. Okay, so there's no solution in the first quadrant. Then we have, if we consider until pi, then we have now one solution. Okay, so from 0 of the right, I'm aiming the right side of the x-axis going to the left side, that's pi. So which means we have this x approximately 2.19. Okay, this one. Then we have find all solutions at the interval or the closed interval from 0 to 3 pi over 2. So until the third quadrant, there's only one terminal side again, so this should be the same way, approximately 2.19. If you extend until full revolution, so 0 until 2 pi, so there will be two solutions this time, this terminal side and this terminal side. That should be x is approximately 2.19 as our x sub 1. Our x sub 2 will be 2 pi minus 0.95. Okay, again, do not use the negative 0.95 because if you will use negative 0.95, that is not part of the interval. Okay, so you have to take full revolution 2 pi minus 0.25. So you have actually x sub 2 approximately 5.33. If you may check, just substitute 5.33 in this function. So you have tangent 5.33. Expect that the value will be approximately negative 7/5. Just make sure that your calculator is set in radian mode. Then you have the next interval, negative pi over 2 to 0. So negative pi over 2 here to 0. Okay, so that should be x approximately negative 0.95 this time. Because if you will try to notice, negative 0.95 is already part of the interval. Okay, so negative value, and you have this negative interval, negative pi over 2 to 0 interval. So of course, this value will be considered in there. Just remember that when the interval is on the left side of the x-axis or starts at the left side of the x-axis, then consider the clockwise rotation. Okay, so clockwise rotation, that means from the x-axis moving down to the terminal side. Then we have final solutions at negative pi to 0. So from negative pi here to 0, again, there's one terminal side. So that should be approximately negative 0.95 as well. Then last, not lastly, but second to the last, negative 3 pi over 2 to 0. So there will be 2. Okay? So notice that it falls. I mean, this terminal falls also at this interval. So negative 3 pi over 2 is here, and then going back to 0, which means two terminal sides will be considered now. One is this one, negative 0.95 approximately, and the other one is negative pi plus negative 0.95. So how did I get that? Well, negative pi is here, this angle, and then to reach the second terminal side, I have to add a negative 0.95 angle, or that should be a negative reference angle. Okay, so that should be approximately negative 4.09. In the same way again, just try to substitute this to x and try to see if it really gives you an approximate value of 7/5. Then lastly, for full revolution, clockwise rotation, well, the same, there will be two values. So approximately negative 0.95 and approximately negative 4.09. Now let's try another example. So we have find all solutions of the equation at the closed interval 0 to 2 pi. given this equation cosine x equals negative 4 over 7. So this is most likely our questions in this course. Every time we give the equation, or every time we ask the solutions for the equation, then we will actually consider the interval. Okay, but if not, then you have to take note. You have to take all the terminal angles of the values of x, or possible values of x. Now we have this illustration, or we will consider this illustration since the value of cosine is negative. And remember that cosine function is positive in first quadrant and fourth quadrant, and so the other quadrants 2 and 3, cosine function will be negative in there. Okay, so the inverse cosine of negative 4 over 7 is approximately 2.18. Notice that this angle is actually an obtuse angle. Okay, and it's positive, so there's actually this portion of the angle here, this part here. Okay, and remember, the reference angle is actually 0.96 approximately, because of course always remember that the straight angle is pi. So from the right side going to the left side is actually a straight angle. So that's pi, approximately 3.14. Of course, from the position here, or the right side of this x-axis, moving to the terminal side here in the second quadrant will be, according to the solution, is approximately 2.18, and so the reference angle is approximately 0.96. Okay? Of course, it follows that this reference angle here also in the third quadrant is 0.96. Just be careful in getting the reference angle. Now to solve for the second value, that should be pi plus 0.96. That means from the right side, this is actually taking the angle in standard position. So from the right side of x, moving towards the left side is actually pi, or 180 degrees, plus the reference angle, so 0.96. So we have this equation now. X sub 2 is equal to pi plus 0.96, or that should be approximately 4.01. Again, in the same way, if you want to check your answers, you can just substitute these two values in this equation. And you have cosine 2.18 or cosine 4.1. Expect that the value will give you approximately negative 4.7. Again, do not forget, set your calculator in radian mode. So therefore, the solutions to the equation are x is approximately 2.18 and x sub 2 approximately 5.32. So that's how you state your final answers. Okay, let's have another one. Find all solutions of the equation at the closed interval negative 2 pi to 0 this time. And the equation is quite or more complex compared to the previous equations. We have sine x equals 3 halves of cosine x. So first thing, or one of the strategies in solving trigonometric equations, is setting all the functions on one side and the other will be the constant value. So in short, we will try to combine the sine x and cosine x in one side while remaining 3 halves at the right side. So meaning, one way of doing it is multiplying both sides by 1 over cosine x. Of course, I am not violating any rules in mathematics here, since I am trying to preserve the equality of the function. I mean, equality of both sides. So I am not changing the idea that, or the given that sine x is equal to 3 halves cosine x. Now, if I may multiply 1 over cosine x on both sides, I will have sine x over cosine x equals 3 halves. Actually, the purpose of multiplying 1 over cosine x is for me to remove cosine x here at the right side, or eliminate this cosine x, because of course when you multiply cosine x by 1 over cosine x, this cancels, so you have 1, or cosine x over cosine x, which is eventually will become 1. And then on the left side, of course, to preserve equality, you have sine x over cosine x here on the left, and that is actually tangent x. Okay, this is a ratio identity. The tangent x is equal to sine x over cosine x. So I can actually replace sine x over cosine x into one function, tangent x. Okay, which is now equal to 3 halves. And so we can now apply what we were doing in the previous examples. In this case, since this is tangent and the value is positive, so I should consider these positions of the terminal side that is in quadrant 1 and quadrant 3. Because of course, tangent is positive in quadrant 1 and tangent is also positive in quadrant 3. Okay? So I may now apply the inverse trigo function. The inverse of tangent 3 halves, and you will have x is approximately 0.98. Actually, if you will try to convert this one into a degree measurement, this becomes an acute angle. Okay, or this is actually an acute angle. So for x sub 1, it's negative pi plus 0.98. Okay. So for what reason? Because we have to take into consideration the closed interval, negative 2 pi to 0. So x approximately 0.98 is actually a positive angle. In short, the rotation is counterclockwise. But notice that this is not part of the interval. The interval or the problem is asking for the solutions within or from negative 2 pi to 0, considering that interval. So negative 0.98 is not part of the interval, so I should take the clockwise rotation. So first, I can say that if I will do clockwise rotation to get a negative angle, then that should be from the right side of the x-axis going to this terminal side in the third quadrant. So how do I get this? That should be negative pi plus 0.98. Because remember that this is a reference angle. This part here is a reference angle. So that's negative pi going to the left side of the x-axis, but I don't need or I have to remove this part here, which is the reference angle. Okay, so I have now negative pi plus 0.98. X sub 1 is approximately negative 2.16. Okay, so again, if you want to check, what's this one? Just substitute negative 2.16 to tangent x, and then you must come up with approximately 3.2. Again, approximate because we have this value as an approximate. Or you may substitute negative 2.16 to x here in the original function, and also to the right side, and then the left side and the right side must have the same values. Okay, then x sub 2 is negative 2 pi plus 0.98 because this is a full revolution clockwise rotation, so negative 2 pi is here, then I have to go back a bit. Okay, I have to go back 0.98, this time positive because I have to go back counterclockwise. Okay, so you have negative 2 pi plus 0.98, or that is approximately negative 5.30. Then therefore the solutions to the equation are x approximately negative 2.16 and x approximately negative 5.30. So we have another example here. Find all solutions of the equation at a closed interval 0 and pi. Okay. Now we have this given equation, negative 3 over 5 secant of x equals the cosine x. Okay. So the same way around, we have to combine all the functions and then isolate the constant term on one side. Now, since we have this reciprocal function, remember that the calculator is limited to sine and cosine tangent inverse functions. So we will try to transform the function secant into 1 over cosine x. Because remember, in the reciprocal identities, secant x is equal to 1 over cosine x. And so we have this one, negative 3 over 5 times 1 over cosine x, transforming the secant x into 1 over cosine x. Okay, for what reason? Again to obtain functions that are available in our calculator, the sine, the cosine, and the tangent. It's quite hard to do the reciprocal or to do the inverse trigonometric of the reciprocal functions. Now, multiply cosine x on both sides. Again, for what reason? Because we want to isolate the constant term alone on the left side this time. Okay, so I have to multiply cosine x here on the left to cancel out cosine x here, or so that this becomes 1. And then do also the same thing at the right side, okay, to maintain equality. Then we have negative 3 over 5 times 1 equals the cosine squared x, or negative 3 over 5 equals cosine squared x in a simplified form. Then to find the value of x, we have to again take the square roots because we are still in the degree of 2. Then here's one thing, no? Here's one thing for this equation, because negative 3 over 5 is actually an imaginary, I mean, the square root of negative 3 over 5 will give imaginary results, okay, or imaginary numbers. And in this case, our x-axis is actually a number line containing real numbers. So that means for this problem, therefore there is no solutions to the equation. Okay, so we cannot have a real number solution here, since the square root of negative 3 over 5 will give us imaginary numbers. So we are not to consider any solutions for this time. Okay, not unless we consider solutions involving imaginary numbers. So for now, again, our x-axis is only limited to real numbers, so there's no solution if ever you will encounter this type of problems. We have another one here. Find all solutions of the equation at the closed interval 0 to pi. Given cosine squared x, actually we need to take the square roots on both sides. Okay, so we actually have cosine x equals positive and negative 1. That means there are two values of cosine x. Cosine x equals 1 and cosine x equals negative 1. When you apply the inverse trigonometric function, that's the inverse of cosine 1, the answer is actually 0. Inverse of cosine negative 1, x is actually equal to pi. Okay, so if you want to illustrate, this is the x and y axis, then we have this part here that is the zero angle, or the angle 0, or that is the terminal side when the angle is 0, right? And that means the cosine value, cosine 0 is actually equal to 1. And also on the left side, that should be the cosine of pi, or cosine 180 degrees in degree measurement. That will actually give you negative 1. And there's no other possibilities of getting 1 and getting negative 1, because in here, if there is a pi over 2 angle or 90 degrees, the cosine value is 0, and also here is 0. So these are actually quadrantal angles, so that means there's no reflection on the other ends. So here we will actually limit our answers to 0 and pi. Okay, so unlike the previous examples, that if there is this cosine, then we consider quadrant 1 and quadrant 4. But here, since this is a quadrantal angle, that means an angle that falls on either the x-axis or y-axis, then there will be no other possibilities. Then therefore, the solutions to the equation are x equals 0 and x equals pi. We consider the two values, okay, because 0 and pi are actually in the interval. When we say closed interval, that means from 0 until pi. So in short, 0 is part, okay? 0 is part of the interval, and also pi is part of the interval. If you are familiar with the open interval does not include, okay, it does not include the boundaries. But since this is a closed interval, then 0 and pi are actually part of the interval. So this is the final answer. The solutions to the equation are x equals 0 and x equals pi. Another one, last one. Find all solutions of the equation at 0 and pi. I mean 0 to pi, at the interval 0 to pi. Secant squared x equals 1. Okay. This time, again, this is a reciprocal function. So secant squared x equals 1, and we can actually transform it into 1 over cosine squared x equals 1. Because remember that secant x is equal to 1 over cosine x, applying reciprocal identity. So we have here now, I can actually eliminate the function on the left side by multiplying cosine squared x on both sides. So cosine squared x times 1 over cosine squared x, and will give you 1 equals cosine squared x here at the right side. Okay, so notice that we have actually the same equation as the previous example here. So this is cosine squared x also here. That means you will come up with the same answers. So x equals 0 also, and x equals pi. Therefore, the solutions to the equation are x equals 0 and x equals pi. So that's it for this topic. Goodbye.